Welcome back. In this video, I will explain the types of semiconductors, the basic types, these types of semiconductors according to the energy band gap. According to the types of energy band gap. So, according to the types of energy band gap, semiconductors are classified into two types: direct band gap semiconductors, indirect band gap semiconductors. So, direct band gap semiconductors. This name explains here. After recombination process, releases the energy in the form of photons, in the form of light, right? So we can write like this: in direct band gap of semiconductors, due to recombination of electron hole pair, is releases the energy in the form of photons. This point is important. So in this type of semiconductors, releases the energy in the form of photons, that consists more light. So these type of semiconductors are also called as direct band gap of semiconductors. General examples are gallium arsenide, gallium phosphate, and gallium arsenide phosphate. These are comes under direct band gap of semiconductors. And these type of semiconductors are used in photoelectronic devices. Okay, optoelectronic devices. So like LED, light emitting diode, photodiode, laser. So those type of devices, these materials are used. So direct band gap of semiconductors. And another type of semiconductors are indirect band gap of semiconductors or indirect band gap materials. So in this subject completely we have to discuss these type of semiconductors, indirect band gap of semiconductors. The definition of this semiconductors explains in indirect band gap of semiconductors. So just you have to write the same points here. In indirect band gap of semiconductors, these points, due to recombination of electron hole pair, is releases the energy in the form of heat here. Okay, so here the recombination process releases the energy in the form of heat, right? So one difference is there here. So here this indirect band gap semiconductor releases the energy in the form of heat due to recombination process, but in direct band gap semiconductor releases the energy in the form of photon. Photon means it consists more light. And examples of indirect band gap of semiconductors are silicon and germanium. These two are acts as indirect band gap of semiconductor. So this heat is also called as, which releases the energy in the form of heat, is also called as phonon. This should be like this, phonon. Phonon means which consists more heat, less light. And here I wrote photon. Photon is nothing but more light and less heat, right? So indirect band gap semiconductors are called silicon and germanium. So now onwards we have to discuss silicon and germanium type of semiconductors. So first of all, I will explain the basic properties of indirect band gap of semiconductors, like semiconductors properties. Those are: semiconductor allows the current in only one direction. Semiconductors allow majority carriers current. Semiconductors allow majority carriers current in one direction. This is one of the important property of the semiconductors. That means semiconductors always allows the current in only one direction only. That is from left to right or right to left, which allows the only in one direction. That current is majority carriers current direction, right? And another important point is semiconductors are electrically neutral. So what is the meaning of electrically neutral? If the positive charge and negative charge are equal, then it is called electrically neutral materials. So in semiconductors, positive charge and negative charge both are equal. That's why semiconductors are always electrically neutral, right? And according to the internal structure, These semiconductors are again classified into two types. So in first case, I wrote according to the energy band gap. Semiconductors are classified into two types: direct band gap semiconductors, indirect band gap semiconductors. Now here I am writing here according to the internal structure. Again, the semiconductor is classified into two types. Those are intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors, extrinsic semiconductors. Intrinsic semiconductors are also called as pure semiconductors. Extrinsic semiconductors are also called as impure semiconductors. Again, this extrinsic semiconductor is classified into two types. One is N-type semiconductor and another one is P-type semiconductor. So we have to discuss the differences between intrinsic and extrinsic and N-type and P-type, how it is defined, and internally one operation is used here. Okay, so that operation also we have to discuss in this concept. So in next videos I will explain that concept. Please take this down.